All right, so on Friday, you're going to be having a test over this entire unit. So it'll be everything that was on your last quiz, plus the things that we do this week. So we're going to spend our time with your videos this week reviewing for the test. So in order to do that, we want to start here on number 14 and work our way through 22 to practice the skills that we did with the circle. Now, you had some trouble with this on your quiz, and I think it was because of the word all. You need to name all that are drawn, not just one. So let's go back and talk about radius. A radius goes from the center to the edge of a circle. So a radius will come from the center point out. That's R. And you have to be able to identify R because you're going to need it in some of your formulas. A diameter goes edge to edge, but it goes through the center. Has to go through the center, edge to edge, through center. Okay? A chord goes from edge to edge. Very much like a diameter, but it doesn't have to go through the center. That would be an example of a chord. And again, we have to pick all of them. So the numbers here to the sides for this study guide, name how many are possible. So you should be able to find 6 radii, 3 diameters, and 5 chords. What I'd like for you to do is to pause the video and try these. If you haven't already, please try them first and then come back and check your work. All right, so hopefully you've got this done. We start at Z, which is the center, and go out, line segment ZU makes a radius. From Z out, ZT makes a radius. Z to Y makes a radius. Z to X makes a radius. Line segment ZW makes a radius, and line segment ZV makes a radius. Those are our 6. Now, you could have the letters in different orders. You could have the line segments rearranged. That would be just fine. But those are the 6. And you'll remember in class, we talked about them looking like spokes in the wheel. Spokes in a wagon wheel, spokes on your bicycle wheel. Anything from the center out to the edge is a radius. All right, so now diameter. We got to go edge to edge. I'm actually going to do diameter and chord at the same time because they're basically the same. They go from one edge of the circle to the other edge. The diameter has to go through the circle, through the center. So if we find one that goes through the center when it goes edge to edge, we'll include it here as a diameter. So I'm going to start with Y. Y, line segment Y to T, goes edge to edge, does not go through the center. That makes it a chord. YT is a chord. All right, let's go on to sticking with Y. Let's go Y, line segment YV. YV is a chord. It goes edge to edge. Does it go through the center? Well, it does. It goes through point Z. So that also makes YV a diameter. And those are the only 2 line segments we have coming from point Y. So I'm going to move on to T. We've already done YT, so I don't have to worry about that. I'm going to trace YW. Sorry, that's not Y, that's a T. I need to go back to kindergarten and learn my letters. Line segment TW goes from edge to edge. That makes it a chord. But line segment TW also goes through the center. That makes it a diameter. Those are only 2 lines coming from T. So now I'll move on to U. We've got UX. UX goes side to side, edge to edge. So that makes it a chord. It does go through the center. So UX is also a diameter. Yeah, okay, got that. All right, no other line segments through U, so we'll move on to V. V to Y makes a chord. We've already got it. It's right here in blue. And it makes a diameter because it goes through the center. But it's already listed. We don't have to list it again. So now let's take the other line segment that has an endpoint of V, and that's VW. We go from one edge of the circle to the other, and that makes it a chord. It does not go through the center, so we will not also call it a diameter. Starting with W. We've already done VW, so that one's already done, and we already did WT, which is a chord and a diameter. So not anything new to do there at W. And if we come on around to X, XU, line segment XU, we already have as both a diameter and a chord. So that's done. All right, so that should have our 6 radii, 1, 2, 3, 4, 5, 6, our 3 diameters, 1, 2, 3, and our 5 chords, 1, 2, 3, 4, 5. Got them all. You'll have to be able to identify them all when it comes test day. Now, the last thing we've got here to go along with the circle is how to name the circle. The circle is always named by its center point. So when we look at this circle, you can see that Z is in the center. This would be known as circle Z. Okay? So those are all of the different parts of a circle that you'll need to know for your test. Let's go on to the next page. Now we want to use this information in order to find the area and circumference of different circles. So it says, Jose has a circular dartboard. I like to draw pictures. The bullseye, right here in the center, just the bullseye, has a diameter of 14 millimeters. I need a scale drawing here. I want to make that bigger. That's the bullseye. And the diameter from edge to edge through the center is 14. We need to use 3.14 for pi, and we're going to find the area of the bullseye, and we're going to find the circumference of the bullseye. And before we can work either one of those, we have to have the formulas. Area starts with the letter A, so the formula for area starts with an A. Now, some of you on your test put the formula for the area of a circle to be A equals length times width. That works for a rectangle. That is not going to work for this circle. Circles are shaped like what desserts? Like pies. So a circle, the formula is going to have pi in it. And we had a silly way to remember it. It was A, red, raspberry, pi. A equals, the area equals the radius times pi. Now in our diagram up here, we've got the diameter. The diameter is 14. All the way across is 14. In order to use this formula, we need the radius just from the center out. In order to find the radius, you'll need to take the diameter and divide it by 2. Half of a diameter is a radius. So if we take 14 and divide it by 2, you know the radius is 7. Now it's a matter of just plugging in the numbers. 7 times 3.14, and using your calculator now to get the answer. The area of the bullseye on Jose's dartboard is 153 and 86 hundredths millimeters squared. For circumference, we have a different formula. Circumference starts with the letter C. So the formula starts with a C. Because this is a circle and it's shaped like a pie, we're going to have the value pi in our formula. And we gave you a silly way to remember it. Cream or chocolate or cherry pies are delightful or delicious. The circumference equals pi times the diameter. C equals, we're told to use 3.14 for pi times the diameter. It says the bullseye has a diameter of 14. You don't have to do anything to that number. It's perfect just the way it is. 14 is the diameter, so you put 14 in the formula. Now the calculator does the rest of the work. The circumference of this bullseye, the distance around, would be 43 and 96 hundredths millimeters. Now, this one would be a good place to use 22 over 7 as a value of pi. You weren't told to, but it would be a good one, because it would be 22 over 7 times 14 over 1, and those 7 and the 14 would cross cancel, and we divide them both by 7, so we get 44 over 1, which would give us another possible answer of 44 millimeters, which, as you can see, is very close. So that fractional value of pi can come in handy if what you're multiplying by is a multiple of 7. Okay, we've got 4 more to go. Now we're looking to find the area of the following figures. So what I'd like for you to do is to try these. We'll come back and check them. Make sure you've written the formulas and you get those formulas memorized. So if we take a look at 19, the formula for a triangle is A equals base times height over 2. You'll remember that base times height works for a parallelogram. And if you draw a diagonal line through a parallelogram, you'll make 2 triangles. So the area of a triangle is only half that much, why it's base times height divided by 2. I traced in the h and found that the height was 6. The line that this was sitting on was 10 feet. This 3 feet here with the dotted line part is simply extra information. You don't need to add it together. You don't need to do anything with it. That is simply extra. So the two numbers, 10 times 6 divided by 2, would give us 30 square feet for the area. The other one, the formula for a parallelogram would be base times height. Again, I traced the h going over the right angle symbol and found out that the height was 5. The h is sitting on the base, which is 15. So using the formula, base times height would be 15 times 5, which makes it 75 centimeters squared. So 2 more to go. The shape that we've got here at number 21 is a trapezoid. And a trapezoid is a little bit more difficult to do because it's got a different formula. You'll remember that we took 2 trapezoids and I put them together and showed you that 2 trapezoids put together, well, that didn't look right. What did I do wrong? Forms a parallelogram. That'll be your secret. Bad drawing of the trapezoid. Secret, secret, there's the secret. I made a really bad drawing of the trapezoid. Anyway, the formula for the trapezoid is base 1 plus base 2 times the height of the trapezoid divided by 2. Because you end up putting the trapezoids together, you get the formula for one big parallelogram, but the trapezoid is only half of it, so we divide it by 2. So now, in order to pick out the right numbers, we have to identify the height. So here is that h. The long side of the h, 10, is our height. What the h is sitting on, that I just crossed out that you can't see anymore, is 20, is base 1 or base 2, doesn't matter. And the other end of the h, the 6 centimeters, is the other base. Now you need to plug in your numbers and follow the order of operation. It doesn't matter whether you put 6 in for base 1 or 6 in for base 2, as long as you add 20 and 6, that's what's important. The commutative property says order doesn't matter. So we get 26 times 10 divided by 2. 26 times 10 would be 260 divided by 2. So we have 130 centimeters squared. For number 22, you have to do a little algebra in order to solve this one. The area of a desk is 432 square inches. The base is 24 inches. What's the height? Well, most desks are rectangular. We know the space inside is 432. We know that the base is 24, and we're looking for that height. So in order to do this, we're going to have to use our formula of base times height. We're going to need to substitute in what you know and then solve. 432 is the area. The base is 24, so 432 equals 24h. To solve for h, we'd have to divide by 24 on both sides, giving us 18 inches to be the height. This will be on your test Friday, something that you probably need to study. I'll see you tomorrow. My 15 minutes is just about done. Good night.